Hello everyone. Today we want to talk about the genetic algorithm optimization by using MATLAB. So for example, we have some functions. As example, y is equal to x minus 1 power 2. And x is, for example, from minus 10 to 10. So if we make a plot for this, we can see that we have this function, and here is the minimum value of this function, for example. And for this function is simple, is like that. So we know that minimum value is 0, but sometimes for some functions, it's really hard to find a minimum value. For example, for this function, for x divided by 1 plus x power 2, so we can see this is the plot that we have, and the minimum value is minus 2. So we can make some optimization method by using the genetic algorithm to find the minimum value. And here we only have one variable, but sometimes we have a couple of variables, and finding that it will be really hard. So for example, first we should define the fitness function, or the function that we have. So here we define that x is the variable that we have, and this is the function that we have. And then we should define that how many variables we have. We have one. And normally the genetic algorithm is useful when we have two different variables. So we can put 2, for example, and then we can put x1 and x2 when we have two different variables. But now we only use one of them. And then we should define what is the maximum and minimum value for upper and lower value for this function. So LB and UB. And then we have some functions, some options for genetic algorithm. So here we just use the genetic algorithm. We can use a PSO and different optimization methods. Here is the population size for genetic algorithm is 50, and the maximum generation is 1. So initially we have 50 as a population size, and we have the different iteration. So if we want to run the genetic algorithm, we have this function GA. First, we put the fitness function. So if you put, for example, y here, then it should be y, something like that. And is number of variables now is 1. And here we have upper and lower limit for this one. Here is for if we have some constraints, for example, some inequality or equality constraints, we can use this one. So the value that we have will go for x optimum value. So we can make a print for that one. And if we want to see what's the minimum value for y, so we can have fval for this one. And then we can see how much is the output and maximum number of iteration. So if we run this, so we can see here the optimum value is -1, which give -2 for us. And the number of each iteration is 60. But the point is that when we have only one variable, x and x2, in x and another x is somehow is simple to find that one. And you can use derivative to find the minimum value. But if we have two different variables like these, then it will be too difficult to find that one by hand. So we have x1 and x2, two different variables. We want to find the minimum value. So then nvar should be -2, and we can use the function like this: -10, -20, -10 to, for example, 20 is a minimum value, maximum value for x1, minimum value and maximum value for x2. And here we can define to show x1 and x2, for example, x1 and x2. And here, because we have two outputs, it will go to x optimum like this. So if we run the simulation, here you can see the value of x1, like x1 is -10. The value for x2 is 0. For obviously that is minimum when we have minimum value of that. But if we want to see, for example, the minimum value for this, we can use the ABS function to show us the size. Then you can see the minimum value is when x1 is 0 for sure.